The object of this challenge is to determine the ratio of heights that 2 rolls of toilet paper should be dropped so that they hit the ground at the same time. One of the rolls is in free fall, while the other is unrolled by being held at one end, giving it both translational and rotational motion. The physics concepts that will be touched on in this video are moment of inertia, which is analogous to the mass of the object, and torque, which is equivalent to force, where torque is what drives the object to rotate.
For the derivation, we have 2 toilet paper rolls, one that is translating straight down and one that is rotating and going straight down. For both of these toilet paper rolls, the only force acting on it is the force of gravity, mg, and the one that is rotating on an axis of rotation. Next, we can go ahead and define the variables. The capital H stands for translational motion, the one that is just falling. The smaller h stands for the one that is rotating and translating. R1 is the inner radius and R2 is the outer radius. We need to find the ratio of the heights, and we know that time must be equal because they both fall at the same time. So we know that the ratio of the heights depend on the acceleration. So if we find the ratio of the acceleration, we can find the ratio of the heights. We know that the acceleration of the one that is just translating is g because the only force acting on it is gravity, and the acceleration is due to gravity. However, for the one that is rotating, we need to find the linear acceleration. Thus, if we find linear acceleration, we can find the ratio of the acceleration and then find the ratio of the heights. We know we need to use the parallel axis theorem because the axis of rotation of the one that is rotating is going through the toilet paper roll. However, from where we are holding it is where the axis of rotation will be, and this is parallel to the center of mass axis of rotation, and the distance between the two axes of rotation is r2. Next, we substitute the formula of the inertia of the cylinder and add the mr square to obtain the inertia. Now we know that torque is equal to force times radius, and it's also equal to inertia times acceleration. We then substitute into the torque formula. We know that the only force acting on it is the force of gravity. So then we obtain the equation torque is equal to mgr. We substitute into the second equation, we substitute the formula of the inertia, and we know that the angular acceleration is equal to the linear acceleration over the radius. We have our 2 equations. We can set them equal to each other and obtain and solve for linear acceleration. Now we can solve for the ratio of the heights. We know the acceleration for the translational toilet paper roll, and we found the expression for the rotating one. And now if we just plug that equation into A and simplify and solve, we get the final expression: 3 over 2 plus r1 squared over 2r2 squared.
In conclusion, we found that the free-falling roll of toilet paper had to be dropped approximately 1.82 times higher than the other so that they will hit the ground at the same time. There were a few assumptions that we made when determining the ratio of the heights, which unfortunately led to some errors. We assumed that both of the toilet paper rolls were identical in radii, however they were not. This had a small impact in the derivation. Air resistance was also negligible. The biggest source of error was human error. Both toilet paper rolls had to be held at the appropriate heights and dropped at the exact same time, which is difficult to accomplish.